Are we ready? All right. Oh, we're recording already. Great. So yesterday we talked a lot about the absolute value being the distance from 0 and do it in 2 parts. And we should really keep it the same today. And so I'm going to show you a couple different methods, and I just want you to pick the one that's going to work the best for you. One of the things that's nice when you're dealing with the absolute values is we're going to have, compared to yesterday, we had the quadratic inside it. Now it's just a linear inside the absolute value. So the number one thing you always want to do is isolate the absolute value. And you still want to think of it as doing it in 2 parts. But if we're adding or subtracting, now it's absolute value of x plus 3 plus an additional 5, or maybe we might be multiplying by 7 up front. You want to get rid of those things so the absolute value is by itself. So if you do it exactly the way I told you to yesterday, you'd say step 1, do x plus 3 is less than 4, and step 2 is negative x plus 3 less than 4. So working in blue, you would subtract 3 on both sides. Working on the red, this is why I have you put the negative sign on the left, is because when you divide by -1, what do we do? Flip the inequality.
Number 1 you didn't solve it. It's 1.
Oh. Okay, I'll go back in a second. Well, I'll do it now. Let's go back and fix 4 minus 3 is 1. Thank you.
Oh.
Want to sneeze again? Anyway, sorry. Okay, here we go. And then we subtract 3 here. Is -7. So there are linears inside the absolute value. They're pretty easy to solve. Do it in 2 parts. It's very straightforward. But you have to show some understanding when you talk about these absolute values. If you think of this as distance from 0, this is telling us that the distance from 0, the original problem is, your distance from 0 has to be less than 4. Right? Can you picture this in your head, what that means? If you own a dog and you let it outside, typically you hook it onto some sort of chain, rope, and it can get 4 feet from the pole that way, and it can go 4 feet that way, right? Your distance from 0 cannot be more than 4 away. Or you're walking through the mall and those parents that put their kid in the little backpack that has the rope tied. I mean, the kid can never get 4 feet away from the parent. Okay, your distance from 0 has to be less than 4. So when we put this on a number line, -7 is over here, and 1 is over here. Can the dog or the kid be out in this area? Or the dog out there? No, they can't be out there, right? Everybody's got to be inside this area. You have to be inside the endpoints. You cannot be to the outside. So your distance from 0 has to be less than 4 at all times. Yeah?
I put like the beginning equation into the graph, and there's like this line.
this should be the look that you have. And so this is another way when you struggle, like people are going to struggle. You guys will get to the test, maybe some of you will blank on how to do absolute value. But if you have the calculator sketch a picture, now it becomes a little bit easier for you to see. Here's your V-shaped graph, and it's asking you when is your graph below, right? When is it below 4? So here's 4. Here's my absolute value. They intersect at these points. And what did we find? -7 and 1. My x values were -7 and 1. So when you're in between here, that's when the graph is dipping below 4. Okay? Make sense? And there we are, we're back. Some of you are going to memorize that situation, and when you do a less than problem, you can say, I want my absolute value stuff to go between -4 and 4. So if you think of your distance from 0, I want my distance from 0 to be in between -4 and 4. Then when you subtract 3 on both sides, your answers, x's are between -7 and 1. Right? That's a shortcut method, and that's for when your absolute value is less than a number. Should be less than a positive number. But, okay. Another method is to take this and set it equal to 0. Okay, so it says -3. Now, if you understand absolute value, it's supposed to be your distance from 0. But what I've done, what does x plus 3 do to a graph? Shifts us to the left 3. So really, we're going to start at -3. So on a number line, put -3 here. Now, go for this direction, and where do I end up? I end up at 1. Go for in this direction, where do I end up? -7. So there's my answer that way too. Lots of different options for you guys to solve it, but it all comes from understanding what absolute value is. It's your distance from 0. Okay? Two x plus 4 is greater than 6. Step 1. 2x plus 4 is greater than 6. Step 2. 2x plus 4 in parentheses with it. Ooh, I kind of messed up. Negative out front, greater than or equal to 6. Sorry about that. So we will subtract 4 on both sides. We will divide by 2 on both sides. The second part, we divide by the negative. What do? Flip your inequality. Subtract 4 on both sides. And then divide by 2 on both sides. Now, this is saying your absolute value has to be more than 6 at all times. Okay? distance from 0 has to be more than 6 at all times. So when I think of it, it's kind of like a restraining order. Grant's bugging me so bad, I'm going to say he can't come within 6 miles of me. Right? So you have to stay to the outside of your endpoint. So when you look at it on a number line, -5 would be over here. 1 would be over here. They're both equal to's. Greater than or equal to, less than or equal to, so they get closed dots. But where do we do our shading? To the outside. So the notation for this would be like -infinity up to -5. You can put a square bracket around that one. U for union, 1 to positive infinity. The U is just a fancy symbol in math for saying and. It's this part of the graph and this part of the graph. If you wrote the word and, that would be just fine with it. So that problem, parentheses, square brackets are involved. You can do it the exact same way as we did before. Set the inside equal to 0. So does everybody have that one written down? You could set the inside the absolute value equal to 0, which you would subtract 4 divided by 2. So you're going to start at -2. Then you're going to go 6 that direction and 6 this direction. I don't think that's going to work. -4 divided by 2 is -2. You got to divide that one by 2 also. If you divide this one by 2, you have to divide that one. So I wouldn't do it that way. I think this is your best bet. Okay? Yes, sir. The original problem is your absolute value has to be more than 6. So if this is 0, go over here to 6, and I can go out here. Then you go back to 0, and now you move to the positive 6, but I can't be on the inside, I got to be away from 0. So that's the understanding you want to show. Less than, you find your endpoints, and you stay inside of that area. Greater than, when your absolute value is greater than a number, you got to stay to the outside of